Welcome to Laws of Indices Level 1. Pause the video now, try the 5 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're simplifying 72a to the power of 3 divided by 8a to the power of 7. Now, since we're dividing indices here, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So starting with 72 divided by 8, this gives us 9, and a to the power of 3 divided by a to the power of 7 gives us a to the power of 3 minus 7, using our law. And since 3 minus 7 is minus 4, we have our final answer for problem 1, which is 9a to the power of minus 4. In problem 2, we're simplifying 11b to the power of 7 multiplied by 4b. Now, since we're multiplying indices here, we're going to use this law, which tells us that when we multiply indices together, we add the powers. And it's important to notice that the 4b has a power of 1 on the b. We can now multiply these two together. So starting with 11 times 4, we have 44. And b to the power of 7 multiplied by b to the power of 1 becomes b to the power of 7 plus 1, using our law. And since 7 plus 1 is 8, our final answer for problem 2 is 44b to the power of 8. In problem 3, we're evaluating 8t raised to the power of 0, and this means we need to find its value. Now, since we have something raised to a power of 0, we're going to use this law, which tells us that anything raised to a power of 0 is equal to 1. And here, since all of 8t is raised to a power of 0, that means the answer to problem 3 is just 1. In problem 4, we're simplifying 12r to the power of 5 q to the power of 9 divided by 6r q to the power of 5. Now, since we're dividing indices here, we're going to use this law, which tells us that when we divide indices, we subtract the powers. So starting with 12 divided by 6, that gives us 2. R to the power of 5 divided by r is the same as saying r to the power of 5 divided by r to the power of 1. So this becomes r to the power of 5 minus 1, using our law. Q to the power of 9 divided by q to the power of 5 becomes q to the power of 9 minus 5. If we now simplify, we get 2r to the power of 5 minus 1, which is 4, and q to the power of 9 minus 5, which is also 4. And that's our final answer for problem 4. In problem 5, we're told that h to the power of n divided by h to the power of 9 is equal to 1, and we need to find the value of n. Now, on the left-hand side of this equation, because we're dividing indices, we're going to use this law, which tells us that we need to subtract the powers. So starting with the left, we can rewrite this as h to the power of n minus 9, and that's equal to 1. Now, since we have h to a power is equal to 1, we can use this law, which tells us that anything raised to a power of 0 is equal to 1. And what this means is that our power here must be equal to 0. So n minus 9 must be equal to 0. And if we solve this equation now, we can add 9 to both sides. And on the left, minus 9 plus 9 is 0, so that just leaves us with n. And on the right, 0 plus 9 is 9. So our final answer to problem 5 is n is equal to 9. It's also worth mentioning that we could have solved this problem by inspection. And what I mean by this is that on the left-hand side of the equation, we can see that we're dividing two things, and the result is 1. This means that on the left, we must be dividing something by itself to give the answer 1. So the left must be h to the power of 9 divided by h to the power of 9, which gives us 1. And if we now compare the two, we can see that n must be equal to 9.